Lesson 2 of the Elements of Anatomy and Physiology. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Elements of Anatomy and Physiology by William Ruschenberger. Lesson 2 of the Functions of Nutrition, of the Nutritive Act. Nutrition is the vital act by which the different parts of the bodies of organized beings renew the materials of which they are composed. To effect this renovation, the animal appropriates certain substances within his reach, which are adapted to this purpose, and these substances, being introduced into the body and distributed to the different organs, are there retained and become constituent parts of them. At the same time that the organs thus acquire new materials, they lose others, which, having become old and useless, are in some way detached and expelled. Thus, then, the new materials take the place of those which have been detached from the organ, so that its substance is, little by little, renewed. When a living being thus incorporates with its organs more material than it loses, its volume augments, and of course its weight increases. Thus, by the act of nutrition, the infant, which at birth weighed only 5 or 6 pounds, is found to have acquired, when it has reached the age of 25 years, more than 100 weight, and a proportionate increase in size. But, if the contrary be true, and the living being loses more material than it incorporates with its organs, it grows thin, as is often observed when the adult approaches extreme age. And when these two phenomena are in just equilibrium, its weight remains the same. This nutritive act takes place in all living beings. Brute bodies, as stones and minerals, are not nourished. The materials of which these are composed remain the same as long as they exist, and if their volume increase, it is simply by the juxtaposition of substances of the same nature as their own. But animals and plants, on the contrary, grow by intussusception, that is to say, by the deposit of new particles within their very substance. The continual process of composition and decomposition, which constitutes the nutritive act, is not perceptible to our senses, but observations have been made which remove all doubt of its existence, even in the bones, the hardest and deepest seated parts of the body. An English surgeon, Belcher, eating of a pig which had been fed by a dyer, remarked that the bones of the animal were red, and, attributing this peculiarity to the colored substances which it had eaten, conceived an idea that analogous means might serve to render visible the effects of the nutritive act. He made experiments which, repeated by a number of learned men, were crowned with entire success. After feeding animals on matter for a certain time, it is always found that the bones are stained red by a deposit of this coloring matter in their substance. And, after having thus fed an animal and then suspending the use of the matter, it is found, after a certain period, that the red matter which must have been deposited in the substance of these organs is no longer there, but has been, as we must conclude, ejected. Now, these facts may be explained by the continuous process of composition and decomposition, to which is given the name of nutrition. This renovation of the constituent materials of the body is indispensable to the continuance of life. When it stops in an organ, that organ decays, and when it ceases throughout, death soon follows. The nutrition of organized bodies is effected by the aid of a liquid which conveys into all the organs the necessary materials for their sustenance, and which serves at the same time to carry away from their substance those particles which are detached by the nutritive act, and destined to be expelled from the body. In plants, this liquid is the sap, and in animals it is the blood. Of the blood. The blood is the nutritive liquid of animals. It is this liquid which maintains life in the organs, and furnishes them with the materials of which they are composed. The blood is the source of all the humors formed in the body, as the saliva, tears, bile, etc. In man, and all animals resembling him in organization, the blood is red. In a great number of others, it is colorless or of a slight yellow or lilac tint. The animals which have red blood are the mammalia, birds, reptiles, fishes, and certain worms called the annelids. The animals with white blood are the insects, the arachnids, that is, spiders and other animals resembling them, the crustacea, a class of animals composed of crabs, lobsters, etc., the mollusca, or animals resembling snails and oysters, and some others. It is a vulgar error to suppose that flies have red blood in the head. When one of these animals is crushed, we see, it is true, an effusion of reddish liquid. But this is not blood, and comes from the eyes of these little beings, whose blood, like that of all insects, is white. Blood is more or less thick and opaque. When examined by a microscope, we perceive that it is formed of two distinct parts, namely, first, of a yellowish transparent liquid called serum, second, of a great number of solid particles of extremely small size which swim in the serum, and which are called the globules of the blood. To these globules the blood is indebted for its red color. They are flattened and have a considerable resemblance to small pieces of money slightly drilled out in the middle. Their form and size vary in different animals. In man, the dog, the horse, and all other animals of the class of mammalia, the globules of the blood are circular. In birds, reptiles, and fishes, the globules are of an oval form. They are smallest in the mammalia and largest in reptiles and fishes. The blood of the mammalia and birds contains the greatest number of globules. In animals with white blood, the globules are colorless, generally circular, and very few in number. When these globules are carefully examined with a powerful microscope, it is seen that each one is composed of two distinct parts, and that they consist of a sort of bladder or membranous sac, in the middle of which there is found a spheroidal corpuscule, a diminutive body. Under ordinary circumstances, this bladder is flattened, and forms, around a central nucleus, a circular border, of greater or less depth, so that, as a whole, it presents the appearance of a disc, swelled or bulged in the middle. The external envelope of the globules consists of a sort of jelly, which is of a more or less beautiful red color, and is easily divided. It is to the presence of these vesicles, little bladders, that the blood owes its color. The central nucleus of the globules is more consistent and is not colored. In its ordinary state, the blood is always fluid, and the globules swim freely in the serum. But when drawn from the vessels which contain it and left to itself, it is not slow to congeal and to present the phenomenon of coagulation. When blood coagulates, the globules unite themselves together in a mass, and little by little separate from the serum, to form a clot more or less solid. Chemistry teaches us that, in man, 100 parts of blood contain about 66 parts of water, from 6 to 7 hundredths of albumin, from 14 to 15 hundredths of fibrin and coloring matter, some thousandths of fatty matters, of several salts, and traces of peroxide of iron. Under ordinary circumstances, we cannot discover in the blood those substances which are found in the different humors formed at its expense. But if we arrest the action of those organs that are charged with secreting these humors, we then find in the blood the matters in question. We must therefore conclude that they always exist in it, but in quantities too small to be appreciated by our methods of analysis, and that the organs just alluded to do not form them, but separate them from the blood in proportion as they are presented. The blood contains all the materials necessary to the reparation and growth of the organs. Consequently, it furnishes to all parts the matter of which they are in need for their nourishment, and also imparts the excitement necessary to the maintenance of life. To appreciate fully the importance of the office filled by the blood in the bodies of living animals, it is only necessary to bleed one and observe the effects of the operation. When the flow of blood continues for a long time, the animal falls into syncope, fainting, and if the bleeding be not arrested, all motion ceases in a few moments, respiration is stopped, and life is no longer manifest by external sign. If the animal be left in this condition, reality soon takes the place of appearance, and death speedily follows. But if we inject into his veins blood similar to that which he has lost, we see with astonishment this semblance of a corpse return to life. In proportion as additional quantities of blood are introduced into the vessels, he revives more and more, and soon breathes freely, moves with facility, resumes his habitual gait, and is completely re-established. This operation, known under the name of transfusion, is certainly one of the most remarkable that has been performed, and proves, better than all we could say, the importance of the action of the globules of the blood upon the living organs. For if we make use of serum, that is, blood deprived of its globules, in the same manner, we produce no more effect than if we had used pure water, and death is not a less inevitable consequence of the hemorrhage. The influence of the blood upon the nutrition of the organs may be demonstrated with equal facility. When by mechanical means we diminish, in an appreciable and permanent degree, the quantity of this fluid received by an organ, we perceive that it dwindles in size, and often even decays and becomes reduced to almost nothing. On the other hand, we observe that the more any one part of the body is exercised, the greater the quantity of blood it receives, and the more it augments in volume. Indeed, everyone knows that muscular exercise tends most to the development of those parts which are the seat of it. That in dancers, for example, the muscles of the legs, the calf in particular, acquire an extraordinary size, while with bakers and other men who perform hard labor with their arms, the superior members or extremities become more fleshy than any other parts. Now, the muscles receive more blood when in action than when in repose, and by this afflux of blood, the nutritive act of which they are the seat is stimulated, and their volume is increased. The blood, in giving nourishment to the organs, and in exciting the vital movement, undergoes a change. It is impoverished not only by the deposit of the particles which the organs appropriate to themselves, and incorporate with their substance, but also by receiving the old materials, which are separated from the tissue of these same organs, and which, having become useless or even injurious, have to be expelled from the body. Consequently, there is a very great difference between the blood going to the organs and that which has already passed through them, and which has contributed to their nourishment. To the first is given the name of arterial blood, and to the second, the name of venous blood. Arterial blood is of a vermilion red. It coagulates very easily and contains a large proportion of globules. And finally, it is essentially necessary to the maintenance of life. Venous blood is of a blackish red color. It is less coagulable and less rich than the arterial blood. But what distinguishes it above every other quality is that after having passed through them, it is no longer capable of exciting the vital movement in the organs. Notwithstanding, the blood thus vitiated does not cease to be useful, because it easily regains its vivifying qualities. By action of the air, the venous blood is changed into arterial blood. It regains its vermilion color and becomes again fit for the maintenance of life. It is this transformation of venous blood into arterial blood which constitutes the phenomenon of respiration. End of Lesson 2. Recording by Mackenzie Nicole Greenwood.